Right, so again, this guy here, transformation matrix A, this is the vector, the relevant vector. And again, we get that vector by saying that P of t can be thought of as 2t to the 0th minus 3t to the 1st plus 0t to the 2nd plus 5t to the 3rd. All right. Now, if we were to take the derivative of that using our early Calc 1 knowledge, we would say that P prime of t would be equal to, well, this wouldn't give us anything. This would give us a negative 3. This wouldn't give us anything. This would give us a positive 15t squared. All right, so we look at the entries. This is t to the 0th. T to the 1st would be the second one. This is t to the 2nd. All right, so from this, we're looking at P prime of t could be equal to, or would be equal to, negative 3 plus 15t squared. All right, because again, how do we define a transformation? I remember being a student, not understanding transformation matrices. The first couple of times I taught this course, not really fully understanding transformation matrices. Probably shouldn't admit that. Actually, that's kind of true for everything I teach. It's like first couple of go around. All right, just telling steps. I don't even really know why it works, but then I have an opportunity to study it over time, and it all starts to come together. So, yeah, but once it clicked for me that a transformation is as simple as deciding where you want to end up, that opened every possibility. Like it opened the door, because in a coordinate plane, you're saying, where do I want I to end up after I make this movement? If I'm flipping over the y-axis, where do I want it to go? All right. Well, instead of having 1, 0, it's now going to become negative 1, 0. All right. I have a matrix that's associated with a polynomial space, or a vector space related to polynomials. Well, where do I want it to go? Now, you don't want to go taking derivatives of these guys, because it all goes down to 0. That would be your first mistake, right? But these are associated with parent functions, so you think, well, where do I want these to go? I want that to go to 0, 1, 2x, and 3x squared. So you have to have some basis for your transformation. You have to have some kind of framework, but knowing the derivatives of your parent functions allows you to create your transformation matrix, which then allows you to apply it to a wide variety of possibilities, right? And in a lot of cases, when it comes to differential calculus, what are we concerned with? Just the slope, right? So odds are we're only concerned with the coefficient in some capacity.
So this is just a problem to like show
Right, exactly. Yeah, it's a very, very rudimentary, introductory sort of thing. Because then you look at it and say, well, now you got e to the t power associated with this. Whoa, that just got way more difficult. Actually, it didn't at all. What's the derivative of e to the t? E to the t. So it plays no role in your derivative, right? So you just think of that as a constant multiple of whatever your answer is going to be. So actually, if you kind of pare this down to just these guys, you're kind of a step in the right direction. But there is some product rule that comes into play here. But I don't want to deprive you of the opportunity of investigating this one on your own. Actually, I think it'll be a very good experience for you. Kind of a feel-good sort of thing if you get these two problems without me showing you how to do it. So, because the first one involves the e, so try that one. There's a little to it, but I think you can figure it out. The second one is to find the antiderivative. And again, just think parent functions. Where do you want the parent functions to go? So find the antiderivative of your parent functions and go from there. All right, so definitely try these problems.